Alright, so for problem 2, you guys can see that we are now kicking it up, as they say. Now we're going to be talking about systems of equations, and one of them is going to be a quadratic, whereas this one is still linear. The way you can tell is the x is squared versus the x being just the first power. They do this way, where they make both equations say y equals. You don't necessarily have to do that. You could just make one of them. So if I wanted this right here to manipulate it to say y equals this, I could then take this right here and plug it in right here. It doesn't matter which way you do this. So this would look like this: x squared minus, and then remember, plug in using parentheses, 2x minus 5 equals 8. So I just took the y out, and then I could get x squared minus 2x plus 5. I distributed that negative sign. That equals 8. I minus 8. I minus 8. And I get the same thing that they got eventually down here, which is going to be x squared minus 2x minus 3 equals 0. You can see that's the same thing that they eventually got. So it doesn't matter how you do that. I would probably do that my way that I did that. I'd only make one of them say y equals and then plug in. They choose to do both. It doesn't matter. So right here, they're going to, I remember we've talked about this extensively. I have x to the second power and I have x. These guys are not like terms. They're never going to combine. So I know right away I'm going to get everything over to the other side. I'm going to make this equation equal to 0, and I'm going to have to solve by factoring. So they factor. Okay. Recording. Alright, so then when we solve, we break it apart, we can see that x can be 3 or negative 1. And then go ahead and you take both of those, they say calculate the corresponding values for y. That means that you're going to take the x and replace it. If it's me, I have the choice. I can, basically we've said these two are going to be where they intersect. I can choose to plug it into this equation or to this. This looks a lot more simple to me, so I'm choosing this one all day long to plug in and solve for. You could use this one, but it just makes more work for yourself. Half of you won't work anyways, so let's do the easiest one. So times by 2, you get 6. 6 minus 5 is 1. So your ordered pair would be 3, 1. With this one, you plug in negative 1. That's negative 2, negative 7. So your ordered pair is negative 1, 7. And those are your two solutions for this. Because remember, we talked about how with this, you can have two solutions when you have a problem. And actually, we're going to go to that next, I believe. They just graph it. When you go to graph this, please make sure you remember some of the stuff that we've talked about. You can do this graphing x squared minus 8. You can do this a couple ways. First thing you can remember is your shifts. I know that this means it's going to be down 8. Normally it's at 0, 0. So they just move the vertex down to 8, and boom, that's where that happens. I can also use some of my other make an x and y chart. For this one, my intercepts aren't nice numbers because x squared minus 8 equaling 0. I have to add 8. I have to add 8, which means I take the square root of 8. And the square root of 8 is not a pretty number, so that's why it's not hitting somewhere nice. So I wouldn't want to use my intercepts on some of them. They'll be nice, pretty numbers, so I can use my intercepts here. Just plug in 1, plug in 2, mirror it on the other side, and boom, you got your graph. For y equals 2x minus 5, you're going to say negative 5 is my y-intercept, so they went down 1, 2, 3, 4, 5, boom. 2 over 1, so they go up 2, 1, 2 over 1, then they drew the line, and boom, you can see those two intersections that we just found. Alright, here's what we talked a little bit about. With a quadratic and a linear, you have 3 different possible solutions. You can have where it intersects twice, because the line actually touches the parabola twice. You can have one intersection, which means there's going to be one solution, or you can have no solution. Notice from our linear, we had one, no solution, or infinite. If you notice, the infinite is no longer in this case when you have a parabola and a line, because there's no way that a line is going to match up everywhere perfectly that a U shape is going to match up. There's no way for me to take this line and map it right onto that U, because a line has to be straight. Obviously the U has a curve in it, so there's no way for them to match up. You can read through some of these things, we just talked about it. This is the one we just answered. Because I'm such a smart teacher, I already answered questions, but do it. Solving each system with two equations algebraically, then verify. So they want you to solve this algebraically, which means you're just going to plug in. And it's so nice because this says y equals and this says y equals. So you can just set these two equal to each other like they did here. You get everything to one side, simplify all the variables together, factor, and you get your answer is -3 or 2. You then take that x, plug it into the easiest one. So I would take this x right here, this -3. And personally, I would plug it into this and see what my y is. I would take this 2, plug it into here, and see what my y is. And that's where you get those two ordered pairs, which are -3, -7, and 2, 8. And then you can graph it. And again, here's where I would use my tools for graphing. I know that since this is standard form, if I want the vertex, it's opposite of b over 2a. This is a great review. So I know it's opposite of b, which is 2 over, sorry, it's a -2, 2 over a 2 times a -1, which then turns this into a -2 over -2, which means my x-coordinate is 1. If you look, your x-coordinate for your vertex is 1. To find the y, I plug 1 in. 1 squared is 1 times negative is -1. 1 times 2 is 2. And -1 plus 2 is 1. 1 plus 8 is 9. And if you look at that, the ordered pair for this vertex is 1, 9. That's how they found it. Then you make an x and y chart, or you can even use, since we know that he's actually, you can factor this guy out itself. Looks like going to be a little bit of pain in the butt. I know they're going to be different signs. Two numbers that multiply to 8, but add to this. My factors in my bubbles are going to be, oops, not negative, that's negative. X minus 4, X plus 2, which tells me that my y-intercepts are 4, or my x-intercepts are 4 and -2. And if you look down here, 4 and -2, that's one way I can graph this sucker. Boom, I've got my quadratic. Again, this is my y-intercept, up 2, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1. Boom, I've got my graph, and that's how they match it up. All right? This should be all review that we're just putting it all together. We have done quadratics graphing. We've done linear. We should have done that. Now we're just kind of combining it all together and showing where the systems do that. This is that substituting in the -3 and finding out what the y is. This is the substituting 2 in, which were these answers from up here. We're just finding those ordered pairs. Just another example. It's the same thing, but this now, they're showing you where it has only one answer. This is what it would look like. Alright, so I'm going to keep the length of this video down, but I'm going to put these up. You should pause and you should look through these and make sure you understand it. In fact, if you want to, just look away and actually try these on your own. Remember, you're going to set these two equal. That's what they do over here. You're going to combine like terms. You're then going to factor. And when you factor, you get the same. It's a perfect square, so you get this answer. And that's why it happens twice. It's because it only intersects it one time. And then remember, you substitute this into the other equation. And that's how you get your ordered pair, that it's 2, -6. Because this only gives me the x. I need the y in order to be an x and a y to give me a solution. So I plug it into here, and that's what they did down there. Same thing here, same process. But when we go to do this, we end up, since I have only x squared here, this is that one where you don't have to factor to solve this one. You can actually just say, hey, you know what? This guy right here, that's the only x. So I can get everything away from the x, which is what they do. They minus the 4, divide by 2, and they square root. But when you square root, yes, it's positive, negative, but it's of a negative number, which means this is kicking out an I, which we've talked about. And so that's why there's going to be no real solutions for this problem. There are solutions, but they're not going to show up on our graph because they're imaginary. So that's just another example. We don't have to plug in because there's not going to be a y that goes with it. All right, then these are just some word problems, but they're basically doing the same thing. The first thing you got to do is they got to come up with two equations. So that's the first things that you see right here is them coming up with equations. You should read through these questions, make sure you understand where they get these equations from. They then say, hey, you know what? Right now, the way that it's written, I can't, what they do is that, like I did the last time, when you only have one that says y equals, they then take the y out of this question and put that in its place, which is what they should have done. Oh, I'm sorry. They're making us say y equals. Sorry. Yeah, this is one of the equations. So they minus x, sometimes this is they minus x, you get negative y equals negative x plus 15. We don't want that to say negative y, so we multiply by a negative 1, which changes all the signs. They're just assuming you can remember that, but I'm pointing it out, and that's how they got this right here. That then can right here take that place. So instead of writing y there, you're going to copy and paste this into y, and that's what they do right here. And then they distribute the 20. They then say, hey, the first thing when I go to factors, I look for greatest common factor. Both of them have x. They factor out the x. Then they get x times x minus 20. If this is 0, that's 0 times anything. I don't care, 0. So x could be 0 or positive 20. They substitute in. They find the two ordered pairs, and boom. All right. What are the two numbers Simon is thinking of? The first number is 20, the second number is 5. Same thing with this one. The only problem is they give us they don't give us, again, any kind of talking through this with this. They give like no way to make an equation except for make an equation from these ordered pairs. And so that's what they do right here. They realize that it's going to be quadratic because the numbers are jumping. They're not, if it was linear, remember it would be, you know, times by 2, times by 2, times by 2, or plus 3, something like that. That would be, so they're realizing it's going to be quadratic. They get this. Then this is another question that they're going to take this equation and set it equal to this. They want to know, so read through this. You should be able to come up with this equation. Again, they've got two equations. Now we set them equal to each other, or they graph it. Set them equal to each other, solve through. Again, just look through this, make sure you understand some of the tips and tricks. If you have a specific question on any of this stuff, or how did they get from here to here, just come see me tomorrow in class. A little star by it. You should write this stuff down. And so this is all. I believe that's it. All right. That's good enough. All right. So hopefully this makes sense to you about solving the systems of equations and what you're supposed to do. We're going to do a little bit more on this, like I said, tomorrow with 3 variables. All right. Have a good night, guys.